Hey,
Okay.
everyone who's watching this recording.
Okay. Anyway, there's Layla. There's Layla. Hang on. Okay, hold on.
Don't forget to like and subscribe. Yo, thanks for the 1,000 bits.
Chad is telling me to start writing on the board.
No.
Don't forget to turn on notifications.
No, not right now, because we got to learn. Okay, please get quiet and listen. Okay, Gavin.
Oh, it's this note.
It's my note.
Okay, I know,
Yeah.
sure, okay. So I was telling yesterday about the course I was taking. Let me finish that. Let me finish what I was saying. So I was saying how it occurred to me, like the moon kept falling into the sun, and like, that's not what really happens. So then I wondered, why wouldn't it? And that's where I get to my cliffhanger. Okay, in a cliffhanger type movie, classically, I think someone's hanging off a cliff. Like somebody slips, oh no, and falls. And very unrealistically, the hero, heroine, whatever, grabs their hand, holds on, and it goes something like this. I'm not sure if I've actually seen a movie exactly like this. Well, no, probably, something like this. Anyway, I've got you. Oh, the grip is slipping. Please promise me you'll never let go. I promise I'll never let go. It's dramatic, right? And then you're thinking, there's no way you can hang on. Look, there's no way he's going to hang on. And then all of a sudden, he jumps off the cliff. And they're both falling. And they're both falling.
Or the door.
And the victim, the one who was like hoping to have their life saved, says, what did you do that for? Says, I promise I'll never let go. I've got you. That's not what I meant. Right? So what does that have to do? What does that have to do with the moon not falling into the sun?
Maybe
They're falling. We're falling together.
Everything falls.
We're all falling
so you
together.
have to make the sun fall too.
Okay, here's the thing. Yeah, okay. Shh. So the reason the moon is not stolen from the earth, it's kind of like if you got robbed and asked if you could go with them. Like, give me your wallet. Okay, but can I go with you? That's weird. But anyway, the moon is falling towards the sun. So's the earth. But wait, they don't plunge to a fiery death in the sun. That's because they keep missing the sun, because they're going sideways. And to paraphrase the Life Alert commercial, I'm falling and I can't get down. You see, if I were to throw a rock sideways, it curves and hits the ground. If I throw it faster, it curves less, but it still hits the ground. But what if you throw it so fast that the flight of its curve, its trajectory, its projectile trajectory, happens to match the curve of the Earth? That's what they're doing. And I tell you, I was very gratified to hear. I was watching a really delightful and rather moving. I mean, look it up yourself. I don't know how you look it up. You can find things on the internet. But it was, that Inspiration 4 crew that I was talking about the other day. People that went up. They came back safely. They're all back. But I saw a Zoom meeting they did with little kids, cancer patients at St. Jude's Hospital, which this was raising a bunch of money for. And these kids, various ages, but they're asking the astronauts questions. And one of them they knew personally because she's one of their PAs, one of their doctors. And she was up there, the one with the prosthetic leg, I told you about that. Anyway, some kid asked a question about what's it like with no gravity. And I'm thinking like, oh gosh, there's gravity. There's plenty of gravity. You wouldn't be orbiting if there weren't gravity. You'd be going, what would you do with no gravity? What does Newton say you'd be doing with no gravity?
Keep going. 'Cause there's
Going in a straight line forever at a constant speed, off into the wild black yonder out there. So that's what you do with no gravity. So it's always been a little bit of a pet peeve for me. you know, when they say like microgravity, 0G. Well, not according to Newton. Actually, when you're in orbit, there's plenty of gravity. That's why you're orbiting. You're just falling all the time. And to my great relief and pleasure, the young woman who's the, you know, the doctor for St. Jude's PA actually said it correctly. I don't remember exactly what she said, but it's like, yes. She didn't like tell the kid you're wrong. You know, that'd be a little harsh. You know.
Like say, well.
But she said it just right, and just like, yeah, like following you can't get down. Did y'all get that? Y'all understand what I'm saying? Here's what the Earth is doing. The Earth is falling towards the sun in the sense that it would go off in a straight line and never come back if it weren't for falling. It's falling, but so's the moon. Now, let me finish my story. Okay, so I realized this. And I thought, why is the moon falling into the sun? Well, because the sun pulls on it harder than the Earth does. So why wouldn't it? It really does. It really does. The sun really pulls harder on the moon than the Earth pulls on the moon. So why doesn't it steal it? Because the Earth's going along for the ride too. It's falling with it. And then I thought, then why is my program messing up? Then it occurred to me that if the Earth were not being allowed to fall, the sun would steal the moon. I thought, how would that happen? That would happen if you didn't put the Earth in orbit. I went back through my notes to the first part of the course, you know, the part where it was like 2 weeks worth of squiggledy squared and things I didn't know how to pronounce in my own notes and everything. And I looked very carefully through it and I found it. The professor had failed to put the Earth in orbit around the sun. Mathematically, the professor had the Earth on a giant popsicle stick. No wonder the moon was being stolen, because the Earth wasn't being allowed to fall with it. Yes?
Can I go throw something away real quick?
Yeah. So I thought, like, could this be for real? I mean, is this a setup? You see what I'm getting at, right? The professor made a mistake.
Wait, so how did everyone else on
Well, here's what happened. This is about 3 days before the end of the course. We got to write a report. You know, everybody's got to submit. It's your whole grade. Your entire grade is some report you're going to submit. And so I'm thinking, like, this ain't going to work. And I thought either of two things. Either professor is just wrong. He just messed up the whole course, or at least that aspect of it. And there's no answer. It can't be done. At least not the way he set it up. Or it's a setup. He's waiting to see if anyone will catch it and be willing to come forward. Which do you think it turned out to be?
The second one.
Here's what happened. I wasn't sure which. So I went sheepishly to his door to his office during office hours and knocked. Yes. Dr. Galland, that's his name. I think I noticed something about the problem. Oh? Yeah, I think the Earth's not in orbit. And I'm waiting for him to go like, good catch. And then he goes like, what? It's like, uh-oh. Oh gosh. Well, he listened to me. He did. We sat down, we went through the notes for about 15 minutes, and he looks kind of concerned, and he says, you're right. And I said, so, about that project, it ain't gonna work, so is it okay if I just, for my report, turn in like, hey, you messed up, or something? No, not in those words, but, and he says, that's all you can do. It's like, I can do that. So I wrote a one-page thing or something saying, like we talked about, you know, it's not, and I showed where the error was, you know, and that kind of thing. But remember those people in my classmates, my like three or four, who wouldn't listen to me, who wouldn't give me the time of day. Yes, it is, almost got it. I didn't say another word to him. I thought he was going to announce it. He didn't say a word. I saw the sweat bead up on their brows. I'm not sure I really saw sweat, but they were looking like a lot more concerned. I didn't say a word. I just sat there like hitting keys randomly, because what else am I going to do? I already wrote my report. I made an A.
Yeah.
Yay!
But what this did, this made me think about the interesting problem of simulating such things on a computer. So, yeah.
Were you not mad that you spent
You
some
know,
of your tuition on a problem that didn't work?
I'm not really mad. I'm blurry. Clear up. Focus. It's weird, it's blurry.
It doesn't focus unless you like stand there and don't move. That's I learned that last night.
Okay, whatever. I'm blurry. You can hear me. Anyway, so this was an inspiration for me to try writing the program myself. And I decided to put more objects in it, like planets going around the sun. So what I'm going to do now is show you, hope it'll show on this, I don't know. I'm going to show you my program, and we're going to have a calculator ready, because we'll see if Kepler's laws work in my program. I mean, we've just learned Kepler's laws, right? So here we go. Be ready to calculate.
Are we allowed to move to better?
Yes, you may. Actually, you can go there.
First time.
All right.
Yay. Where's the calculator?
This one, unlike that one, has graphics. Yeah. Now, I apologize for it being small.
Can it run Zoom?
Everybody listen. I'm sorry it's so small. That's because I wrote it in a much older version of Windows.
Size doesn't matter.
And, well, yeah. But, and also it does not help to do this. You see what I mean? That doesn't help. But anyway, you can see it. And let's see what's in it. It has planet number 1, planet number 2, planet number 3. I can do 3 planets. They're all going to go around the sun. I've got them at different distances from the sun in AUs. I've got different launch speeds. I've got some numbers here. I actually want to change this number. That 0.01 is really to a 0.1. I'm going to change to 0.01. There's some other inputs, like iterations per interval. That determines how quickly it's going to do its calculations. I've also got a mysterious thing. If you know what this means, don't say it. Power of R.
It means power of R.
Yeah, that's what it means.
Why'd you say it?
And then screen whip. Okay, that's easy. Watch. And off they go. And they're not going very fast. They're going very slow. Let me quit that for a second and make it go faster. That's too many iterations per interval. There are 2.
That was cool.
There they go.
We're zooming.
Oh.
They're going around.
Whoa.
I'm sorry it's small like this. That's quite small actually.
What planets are
Can you
even
click
in
on
this?
These are just some made up planets, and they're orbiting the sun.
If you do
And
it
I'm
full screen,
still going much
it's bigger.
slower than I meant to go. I can speed it up some more.
So you coded all of this?
What again?
You coded all of this?
Oh yeah, I code lots of things.
If you make it
That's
full
really
screen, does it
impressive.
make it a little bit
Thank
bigger?
you. So anyway, what you
Okay.
see these planets doing, and it's also running extra slow here because it's actually a 16-bit program running on a 64 thing with an interpreter thing doing it. But anyway, here go the planets. They're going in like circles or something. Look at this one here, the yellow planet. The yellow planet, let's see its distance from the sun. It's currently, it's number 2, it's currently 4.01 AUs from the sun. The closest it's been is 4, the furthest is 4.01. What's the average of 4 and 4.01? 4.005. Just call it 4 for a second. What's 4 cubed?
64.
64. What's the square root of
8.
64?
8.
8. Therefore, this planet should take about 8 years to go around the sun. Now, it's been, what, 6 point something? Can y'all read that? It's kind of small. I'm
7.
sorry, it's so small.
Yeah.
It's like
Point
7.
something.
Be like exact.
I'll hit the pause button when it looks like it's
7.5.
done. It's almost done, almost done, almost done. Pause.
8.03.
Yeah, and you know what? It was just over 4 for the average anyway, wasn't it? That makes sense. So it just obeyed Kepler's law of what?
Wait,
Periods.
No way.
Let me change some numbers. I'm going to quit that.
It doesn't.
I'm going to go to, I'm going to make all the planets start out 4 AUs from the sun I will make this one go. I feel like making it 19. And I'm going to try to speed it up a little more. It's kind of going awfully slow. I wish it wasn't so slow.
All of the orbits look pretty monolithic.
I'm going to make this.
What?
There, that'll be faster.
Oh, wow.
Here goes. Let's watch these planets go around the sun. And they're off. Now, look at the purple planet.
That's really cool.
Oh, look at it go so fast. Look at it go so fast.
Jesus.
Now, actually, that's really sad because that just totally defeated my point.
But that was
The interval's too big. This program's running too slow. I'm so sad about that.
I'm sad too.
You're gonna have to slow it down some. Ready to work right.
Look how flat it is.
This really just proves that the Earth is flat, and the Earth's not even on there.
Okay, so what you're gonna see
Wait,
here,
so
this
that
is
proves
running painfully slowly.
We are flat.
Well, it doesn't prove anything.
It's not, but
Does it fast
Okay,
forward?
shh.
Is it a
Watch the
phone?
purple planet. Do you see how the dots are getting further and further apart?
No, I can't see.
Oh, they are. It's going faster because it's closer. What
Lava
shape
wheels?
does that orbit appear to be, the purple planet's orbit?
It's better.
Probably an ellipse. With the sun maybe at
The
one
focus.
of the
One
two
foci.
foci. Now, again, I've had to like compromise a little bit. It's going to work pretty well.
Mr. Aaronspurger?
Yeah,
So the purple planet, is that planet 3?
it's planet number 3. You're
So
right.
does that mean when it's as closest as it is to the sun, aka the minimum, that's the same distance Earth is to the sun? as
It
the
is
sun?
in this case. Yeah, that's the way it worked out. It happened to be that way. Now, notice its distance from the sun varied from 1 AU to 4 AU. You can calculate the eccentricity. 4 minus 1 over 4 plus 1 is 3 over 5, which is 0.6. The period of that planet, we didn't bother to check, but if you had added 1 and 4, divided by 2 to get our average is 2.5, and you cubed 2.5 and took the square root, you get 3.94, and that's what its period was. Anyway, look, so what I'm saying so far is you've just seen planets obeying Kepler's laws, right? By the way, the white planet is way the heck out yonder, and the program is running so slowly. See, we're up to 9 years. Tell you what, while it keeps going here for a minute, let me tell you something. Okay, so you've just seen a program obey Kepler's laws, right? Yes.
Are you gonna show us the cube, like the 5-dimensional?
Oh, that well, maybe sometime. All right. Okay, so anyway, you just saw this thing about Kepler's laws. You think like, well, yeah, because I know Kepler's laws, and I'm trying to teach you Kepler's laws.
Are we
So
gonna
make
make
a
it
program that
disobey them
demonstrates.
now?
What again?
Are we gonna make it disobey them now?
You got it.
Let's go.
Okay, it's gonna
The
happen.
variable.
So here's the thing, before we make it disobey, let me tell you this.
Oh, this.
This program absolutely does not know any of Kepler's laws. I wrote the program, so I know what's in it and I know what's not in it. Nowhere in this program is there any hint of an instruction to go in an ellipse or for the sun to be at one focus. Nothing in the program tells it to have the squares of the periods proportional to the cubes of the radii. How in the world could you obey laws you don't even know?
That's
Well, I'm not
If it's
flying
constant.
away, so.
Right. Well, now, let me give you an example. Could you possibly go to some faraway land and just accidentally not get in trouble with the law?
Yes.
I've done
Yeah. In fact, I got a
Is that a
suggestion here. Here's my thought experiment. You go to some country and you come home and you didn't get in trouble at all, and you find out later they had these crazy laws. They had this law that you can't kill people.
What?
Whoa, I said,
Yeah, they have a law that you're not supposed to kill people. Whatever. When in Rome. Okay. And then they have a law. They have a law that you can't steal from people.
Y'all listen.
Whatever.
They call
Random.
it though.
And then they have a law that you, yes. And then they have a law that you can't call people bad names. Now that might, I mean, a little freedom of speech issues there maybe, but still, that's their law. And you know what?
Man, the pursuit.
You didn't do any of those.
I
You know
did.
why? Because you
Every day.
obey a deeper, more profound, fundamental law. Do unto others as you'd have them do unto you, or something like that, right? Look, you don't have to know all those laws. You just have to abide by something deeper. And you know what? Isn't that perhaps a unifying theme among all those crazy, wacky laws they have? Now here's the thing. You already understand the logic behind laws like I just mentioned. What you don't understand, perhaps, is the logic behind laws like thou shalt travel in elliptical orbits with the sun at one focus. And while you're at it, a line drawn from you to the sun shall sweep out equal areas and equal times, and you shall have squares of your periods proportional to the cubes of the average distance from the sun.
The 11th, 12th, and 13th commandments?
Yes, exactly. So, but why? It's here, and what Rhea was asking was like, can we make it disobey? Well, first let me see where we're at. This is being painfully slow. Let me tell you why it's slow. They gave me a new machine that had Windows 10 and won't run my old 16-bit programs unless I convert them with some fancy conversion thing that they gave me to do. The trouble is when it convert it, it makes it about 20 times slower than it was on the old machine. So I'm sorry it's so slow. I tell you what though, before we leave this screen, you see the white planet? It's gone way off yonder, off the screen, hadn't it?
So full screen?
Has it escaped? Well, I'm looking at the numbers. It is not escaped. Look at this distance. It is coming back. Now, maybe it could have escaped, but it didn't. It's coming back, and before it gets back, we need to have dinner ready for it. I mean, we heard it's coming over, but when? Let's compute it right now with your calculator. So let's see. So look, the furthest it got was 17.5 AUs. The closest it got was 4. What's the average? Calculator time. What's the average of 4 and 17.5?
10.75.
10.75. Please do what with that? Cube it. Raise that to the third power. Then do what with that? Square root it.
Can you do that in your head, Mr.
I know it's 30 something.
10.75 is the cube.
Cube that, then take the square root.
35.25.
35.25. So our prediction is the white planet shall return at 35.25 years. But I don't know. It's been 32 almost years. I don't see any sign of it. You sure we shouldn't just go ahead and eat without it?
He's just fast.
Fast?
He's
Coming in fast, maybe. I don't know. It's been 32 and a half years. It's only 3 years and dinner's almost ready.
Can I go full screen?
No, it doesn't help.
Oh, okay.
I wrote it in 16 bits. It's not going to do it.
Oh my goodness.
Look.
He's coming. Hide the kids.
Clip that.
Everybody, ding, 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 ding. The little triangle out front on the porch.
Yo, there's
ding,
pause
ding,
in
ding,
the
ding, ding, ding.
The British are coming.
No, not the British.
Hey, look for 35.25. Here it comes. 34.7. Right. About, I'd say, now. Oh my gosh.
Okay, that was actually really...
Nailed it.
No,
So
It's almost like it's a long.
So here's the thing. How do we come up with an evil twin universe
And stop signs.
where it's not obeyed? So what I'm going to do,
Where it's not a what?
where these laws are not obeyed,
Oh, I think you said
So
it.
there is a thing I can change here. Power of R. I'll change power of R. I won't change it too much.
100.
I'll just make it like negative
9,001.
2.2.
What happens?
Oh!
What happens when you change it to like a positive number?
I will.
Okay.
Death, like everything.
And here we go.
How do we travel this year?
Okay, again, I
Spatial
apologize for
distortions.
the slowness of the program. Usually be a lot quicker. But you remember what happened last time we made it -2? We got a nice elliptical orbit here for this purple planet. And so far, it's not showing many signs of doing anything else.
It's gonna hit the sun.
By the way, we didn't check the law of Aries. Remember the V at perihelion times the perihelion equals the V at aphelion times the aphelion?
Yes.
Yeah.
Okay, so you can see that here. We're about to pass this point right here. Here we go. So what you can do is you can take the minimum
Okay.
distance
Okay,
times
he's
the
gone.
longest,
He's gone.
the biggest speed. So like 1.18 times 18.73 and that times.
Universe
Oh no!
Universe crimes.
Oh no!
Hey yo, that sun's getting kind of close though.
We no longer have an elliptical orbit.
This is
In
It's
fact,
an egg.
I'll
This
go
is
ahead and
fine.
tell, it's not even that.
It's a fish.
In fact, it's already violating one of Kepler's assumptions. Remember one of Kepler's assumptions was planets' orbits repeat?
So it's not.
It will
rotating.
never do the same thing twice. I've tried. It will never do the same thing twice. There is no, in this universe, there is no such thing as a period. There is no planetary orbital period because it never repeats itself. Similarly, well, our average, I don't know how you'd even define it now. Let me tell you what it does obey though. If you'll multiply 1.18 times 32, what is somebody do that. What's 1.18 times 32?
37.76.
37.76.
Yeah.
Now multiply 4 times 9.42.
37.68.
You know what it just did though? It just obeyed Kepler's law of Aries. Weird. In this universe, I've just trashed the law of elliptical orbits
But kept
and
it area.
I've trashed the law of elliptical orbits. I've trashed the,
Assumption of.
yeah, so now you can kill people and steal from them, you just can't call them bad names. Yes.
So is it from now on just gonna go in like this?
non-comparative religion
Actually,
wouldn't
what'll
get it.
happen, I've done this before when it ran a lot faster,
dick.
and the white planet never ever comes back.
That's
That's tough. Anyways.
This one makes big, wide, loopy things. This one keeps doing that. But let me go to a different
Wait,
universe.
so it is repeating though.
Wait, Mr.
Okay, listen.
If it makes
Yes,
a pattern.
question.
What's
Yes.
the funniest number we can change power?
Well, let me do this
69.
one.
Probably 69.
Then it asks for a positive number, I'll do it.
Wait, Mr.
420.
Transformer?
I'll tell you what, I'm gonna speed things
69,
up a little bit by
420.
just making them faster.
Planets
Oh, yeah.
are actually just gonna go.
I'm just gonna make them faster. I don't know,
Make
just
each
different
one go
speeds. I'm just making up random crazy
69,000
speeds.
20
What
meters
does
a
the
second.
power of R do?
That's what we're gonna
Gravity.
learn.
So this kid's just called
I've just changed to,
Retrograde.
power of R is 1. Let's watch what happens now.
It's gonna go faster, right? Oh, it's going faster.
Holy crap.
Speed.
Yeah, I made them go awfully fast. Oh, look, they met.
Oh.
They
Planets collide.
Each other.
They're going
Oh,
to
that's actually really cool.
meet
Looks like an
again.
eyeball.
It's an eye.
Yeah, let me
That's
let me
sussy.
make
Is there any way
the
we can make a
interval
planet hit the
smaller.
sun?
Here we go.
See that.
You look depressed.
Watch this again. I'll
Never
slow this
ever
one
say
down.
sussy again.
Funniest thing ever.
Ever. Never say
You look
that
like
again.
you're about to
Sussy.
Here goes.
I am.
Amen.
Watch what they do now.
Please hit the sun. Please hit the sun.
There is one. Oh, there is one. I'll tell you about a real weird one in a minute. But.
I want
Okay,
Where
so-
did Planet 1 go?
They're
Planet one's
they're
just
like-
gone, dude.
Fly
No, they're
me
like right
to
next
the
to each
sun.
other.
What
No.
did you make power of
Now, look at this shape. It's interesting. This is actually going to be an ellipse. However, unlike in our universe, this evil twin universe of ours has a different law of Kepler. In that universe, Kepler really did kill Tycho. But anyway, what happens in this universe is that orbits are ellipses with the sun at the center.
So it's not.
Not one focus, but the center. And the law of periods, look at the time. 0.8, 0.81. Watch these two planets with totally random different things. They are both finishing their orbit
That is so
right now at 1 year. In this thing, your test is easy. What's the period of the planet? One. What planet? All the planets. In this universe, every orbit is an ellipse with the sun at the center, all periods are the same, namely 1 year. And guess what? The law of areas still works. The law of areas is impervious almost to power of R, whereas the shape of the orbit and the law of periods and whether or not there is one depends on it. Yes?
So what I noticed was like the yellow and white planets are now orbiting together.
Oh, I didn't mean them to, but they did. Did I watch? Oh, I watched them the same speed. But that's worth saying. The reason they did the same thing is because I put them in the same place and watched them at the same speed. Thank you for noticing that. You're right, they did. Bennett, you had a question?
Basically the same thing.
Same thing. Emma?
So basically the red one is going faster, and that's how they end up at the same place?
Actually, the red one and the white one were. Oh, well, you mean the same place as the purple one?
That's how they end up at the same
Yeah, I mean
place.
it's weird though. You know, what I'm really telling you is that that Kepler's laws are contingent upon, depend on this mysterious thing called power of R. Now, what I'm going to do. Usually this thing runs a whole lot faster than this. I'm going to set something up, let it run for a while, then show you again. And we'll learn other stuff in the meantime. It's just too slow today. What I'm going to do, I'm going to make a crazy power of R5.
No.
I'm going to make the
Divided
time
by
interval a little shorter and launch at crazy speeds from different
What could possibly go wrong?
distances.
That's so wacky.
Like
That's
1, 3, and 4. I'll make them different colors.
Oh Lord.
Oh, we're gonna have an orange planet.
Oh, let's
Yay,
go.
orange.
And a green planet.
Let's go.
And a cyan planet.
Sucks.
And I'm gonna set them off to
Science
have fun.
Science
Can you make the
sucks.
red planet zoom?
I'll do like I'll do.
What if we did
That was so
role
flat.
play?
No,
Whatever.
no, that ain't good. That ain't good.
Perfect, they're off.
They go!
Bennett, do you have perfect fit?
No. I don't
Okay,
think
so what I'm gonna
You're
do,
just going
I'm
straight.
sorry, I'm gonna minimize that so you can't see it so we can learn other stuff while it works. And
No.
let's learn other stuff and we'll look for the end of the period, see what pretty thing it made. Okay, so back to your seats. So I made my point, I think, that Kepler's laws depend on something, and that something is power of R. Now let me tell the historical part of this. Here's how this all happened. First of all, Kepler wanted to know why his laws were true. He suspected it was a force. He was wrong about the force in two ways. He thought it was magnetism. It's not. He also thought the sun was doing like that to the planets, and it's not. He's wrong, and then he dies. He's both dead and wrong, and dead wrong.
Wrong in your.
He was dead
Okay.
wrong.
But right about the time he dies, someone else was born.
Newton.
Isaac Newton. Isaac Newton was born on Christmas Day, 1642, at least on the Julian calendar. They changed calendars later.
Birthday, Isaac Newton.
So let me tell you about Newton. Here's a little bit about Newton. Newton was born to a mother whose husband had just died. So he was born fatherless. But or maybe by the time he was born, they married her off to the preacher down the street. She couldn't be like single and stuff, right? So, they married her to somebody. Now, you know how those awful nature things where like the new lion takes over the pride and like eats the cubs of the other lion?
Yeah.
Well, I'm not saying his preacher stepfather ate him. He didn't. But he kicked him out of the house.
Okay.
So Newton is like not living with his family. They sent him, well, for a while, he lived with the local apothecary. What's that?
Oh, that's the place where you go to like get herbs.
Yeah, the drugstore basically, but it's like CVS and 16 something,
And it's fancy and it's.
Oh yeah, and you know what? For a little kid who happened to be very bright, for a little kid to live in a place with all kind of like chemicals and stuff around, it was really neat.
That
So he
was
got
so
to play
much
with all
fun.
kind of stuff. So maybe it wasn't so bad. He did see his mom sometimes. He had a sort of a love-hate relationship with his mom.
It's not me.
He loved his mom, but she was willing to take her new husband over him. You know, it's hard to say how much choice she had in the matter, but anyway, that was the way it worked. By the way, Newton wrote when he was like in college.
Principia?
Well, no, he didn't write Principia in college. He wrote a list of his sins.
Oh.
And I have read, you can read it on the internet. Isn't the internet great? You can read a list of Newton's confessions. Among his confessions, one of them was fixing a clock on the Sabbath. That's naughty, okay? He confessed that. He also confessed to having lied about a louse.
Like a little bug?
Like a bug. He lied. I don't know if he said, there's a louse in your hair, and there wasn't, or something like that. So the guy's pretty hard on himself, right?
Making a feather while on that day.
Yes, and then you get to the one where he confesses, having wished to burn down my house with my mother and father in it. You go from there's a bug on you and there's not to I want to burn my parents. Okay, yes. Yes. Why would he have a problem with his parents? They kicked him out, the poor little kid. Anyway, he grew up in the apothecary's house part of the time. There was an uncle that kind of would take care of him some too. But everybody recognized he was a smart kid. So they got up the money. They weren't poor. They had some farmland. They weren't like noble or rich, super rich or anything, but they did have some land. And they knew some people. And so they came up with enough money to send the kid to Cambridge. He goes to Cambridge. He's very smart. They kind of figure that out. School's his thing. School's going just great. And then they close school.
Pandemic!
Yes. Hey, familiar, right? And they didn't even have Zoom.
Hashtag relief.
Yes, hashtag, yeah. So, but anyway, so the pandemic comes along. It's way the heck worse than this one. This one's serious. I agree. But a third of the student body dying instead of just having to be on quarantine, that's serious. So they close school for a year and a half, and he goes to the farm. While he's on the farm, his uncle's farm at Woolsthorpe, he has lots of time to think. Now, I got to say, it's interesting. You're coming up on your peak of mental creativity.
Oh,
An
no.
awful lot of the innovative breakthrough ideas in the history of science and the world in general have happened in like 20-ish year olds, 20-something year olds. So anyway, yeah, I know, I'm over the hill. So in any case, he sits on the farm, he looks at the moon, apples fall, I don't know, he gets a lot of ideas. He wonders things like, why doesn't the moon fall? And then he thinks, wait a minute, it is. Because Newton realizes that the natural thing to do is to go in a straight line at a constant speed, and the moon is moving, but it's not in a straight line, it's actually arcing towards the earth all the time, so the moon's falling and it can't get down, and he realizes this. Other people are thinking like, what holds the moon up? But no, he doesn't think anything holds the moon up. It's being held down. And he sees apples fall towards the ground. And he goes like, whoa, the red shiny ball that just hit me on the head was headed toward the center of the earth. That ball up in the sky is headed toward the center of the earth. It keeps missing, but it's headed, it's trying. Whoa, maybe the moon is subject to the same laws the apple is. These ideas fester in his mind, in his young mind, and then he goes back to school because the plague's over. And he finishes school and he stays at school. He becomes a professor, apparently a notoriously boring professor. So much so that there's a story. You see, every now and then Mr. Faison will come in this room to watch my class for about 10 minutes because he's supposed to. Maybe Mr. Merrill or Miss Zintz or something. And they come in for a few minutes and watch and leave.
Is Mr. Faison the head?
Yeah.
He's the head of the science department, yeah. Anyway, some administrator guy at Cambridge, Trinity College in Cambridge, the story goes, came in to observe Newton's class. He heard Newton talking like this. He looked in the room, and it was just Newton. Everybody was skipping his class. And Newton figured, I don't care if they're here or not, I'm teaching this anyway. So he just like was talking to himself. That's Newton. Newton goes through his career doing some neat stuff. He invents the Newtonian reflector telescope. Most of the telescopes in this room, not all of them, but most of them are Newtonian reflectors, where you have a mirror in the back, a little side mirror that shoots it out the side. That's Newton's thing. He got sort of kind of famous for making that telescope. He's also the guy who did the prism thing with the white light going in the prism and made different colors, the rainbow, and put it back together again. That's Newton. And yeah. And if Newton had stopped with that, you might have heard of him in some course. Instead, he's a really big deal. He's a big deal because of what came next. So you get to the 1680s, about 1680, and Newton is a depressed, middle-aged guy with cats.
Mood.
He actually invented the cat door. And he had a big one for mama cat and a little one for the kitten. He could selectively let different cats in. Anyway, and by the way, he did that so he could do his experiments in the dark. So the cats he wouldn't have to open the door all the way up and ruin his night vision. But anyway, so he's kind of in a funk, sort of. He doesn't really have any friends. And he's a member, though, of the Royal Society of London, which is a kind of a new thing in the world. A social group of scientists who actually talk to each other instead of working in complete isolation. Oh, dang it. We got more to learn. Anyway, you get the idea that Kepler's laws need an explanation. I made there's a handout I told you about, a PDF about Newton and gravity. Read that. Read the rest of the chapter. Oh, yeah, let's look.
Is homework still due tomorrow?
No, it's not. Thank you for saying that. I'm not going to make it due tomorrow. I haven't gotten as far as I meant to be. I haven't gotten far enough. My apologies. It's just a lot to say. Oh no, it erased.
Wait, they're still
It
doing
erased them. They're still moving, but it erased all the old stuff. I'm so sorry.
We can look at
Oh.
it next time.
I'll just leave it run. Oh, I'll have to do it again sometime.
Okay.
Sorry, it's so slow.
Yeah.
It's this like fake 16-bit thing. Fake
Is
64
this a
bits.
lodestone?
It is a lodestone.
Do you have a paper clip?
Yeah, I do right
Oh, yeah,
here. Pick it up.
I forgot my bracelet, and my bracelet's my pen.
Yeah, see that? It's a lodestone. It's a load of lodestone.
I'm gonna buy one of those.
Do I see y'all tomorrow?
No.
No.
Oh, man.
What, do
Okay.
you?
Sure, sugar.
No, what's the very
No, we started at 4 yesterday.
Okay.
I just wanted to say happy equinox.
Oh, it's the equinox. 3:21 p.m. today. Sun's on the celestial equator. 3:21 p.m. today. Happy equinox.
I want to go back to the parade field during
Thank you.
I mean, I would like to go to the parade field during tutorial.
What's on the parade field?
Like, because we were there, not the parade field, what do you call it? The one back.
Oh, that field.
Yeah, is that the parade field?
You know, the parade field's is over there.
Okay, I'm confused.
Yeah, that's the, I don't know, practice field or something. What do you call that field? The one outside my
The
window.
astronomy field.
The outside the astronomy window field.
Yeah, that field.
Yeah.
To see the sun.
Well, it'll just kind of look the same, but I mean, it'll have the regular shadow like it did yesterday and the day before. It'll just be a certain length and not those lengths. But if you want to know what west is and east is, not that you wouldn't know anyway, you can watch the sunset and rise now. So it'll be like due east, due west today.
Yes.
We're very close.
Also, I found.
I know, aren't they great?
Punching my sister,
Yes.
robbing my mother's box of plums and sugars.
I love these. And then these kind of vague ones.
Idle discourse on my day and at other times.
Peevishness with my mother.
With my sister. What?
What with his sister?
Peevishness with my mother. Peevishness.
Oh, peevishness also, yeah.
Like how
Fierce man above the.
Did you run across the burning down the house thing yet?
No, not yet. Striving to cheat with the
understand.
rat's house.
a brass half crown.
There's a lot
I don't
of
know
twisting
what
it like
Cord on Sunday morning.
Twisting a cord on Sunday morning. Not desiring thy ordinances. I don't even know what that means.
Okay.
No. Not loving thee
Beating
for my
Arthur Storer.
No,
Be in trouble
beating.
with this Arthur Storer.
Beating Arthur Storer. Not loving thee for thyself.
I know there is one about it might be a different list, you might have done more. Oh, denying crossroad to my mother, though I knew of it. Oh, like
Yeah,
you
that's
got a
classic.
stealing cherry cause. He has trouble with the story. Arthur and Edward.
Do the noise, do the noise.
Do it, do it.
Get him to do it, I'll see what I hear.
Threatening my father and mother Smith to burn them in the house over them. You should write that on the board.
The way that one stands out. Wishing death and hoping it to some. Striking many.
Having unclean thoughts, words, and actions and dreams is. Dreams is.
This is great. Hey, by the way, what we're looking at
We're looking at
is a list of
Newton's
Newton's sins.
Who needs WA confessions when you have Newton's confessions?
I think I'm going to pull that up. If we're talking about Newton, we need to know what he did wrong, right?
Yeah.
Okay.
Apparently a lot. And then
Oh gosh. Oh, you're right. Remind me of them. Okay.
And then
Yeah, I'll pull it up.
Missing chapel. Twisting a cord on a Sunday morning. Twisting a cord on a Sunday morning. I don't think it's alcohol. He was a kid for this. Oh shoot, I really forgot.
Okay. Isaac Newton.
Bye, Mr. Rinsberger.
Bye. Isaac Newton was a very self-critical, conscientious guy. And we can briefly look at his recorded sins. Let's see, we have making a feather while on thy day. Denying
Eating an
that I made
apple
it.
at thy house.
Yeah,
How terrible.
squirting water. Squirting water on thy day. Carelessly hearing and committing many sermons. Refusing to go to the close at my mother's command. Look at this one. Threatening my father and mother Smith to burn them in the house over them.
Wait, what? Wait, Mr. Expert, what's this?
That one stands out a little bit from the others, doesn't it? Wishing death and hoping it to some. Wow. Striking many. He's a bad boy. Okay, let's play. And then, look at these others. Calling Dorothy Rose a jade. Gluttony in my sickness. He ate too much while he was sick. Idle discourse on thy not loving thee for thyself. Fearing man above thee. Religious guy, very much so. Beating Arthur Storer. Peevishness at Master Clark's for a piece of bread and butter.
Wait, Mr. Expert, what's this website?
This brain pickings is this one. Reading the history of Christian champions on Sunday. Twisting a cord on Sunday morning. I'm not sure I get that one. Twisting a cord. Here's a little peek into Newton. That's him. That's the guy whose laws we're learning about. He worried about lots of things. And why would he threaten to burn his mother and father Smith in their house?
Because they kicked him out of the house.
Yes, because Newton was born to a mother whose husband had just died. And she remarried, and he was like in those nature shows where the new lion takes over the pride and eats the cubs.
Wait, what?
I'm not saying that his stepfather tried to eat him. I am saying that his stepfather said, I don't want that other man's spawn in my house. Basically, Newton's stepfather kicked a little kid out of the house because he wasn't his kid. That is sad. He went to live with the local apothecary. What's an apothecary? It's the drugstore. It's CVS. It's the CVS of 17th century England. Or herbs and all kind of chemicals. And you know what? For a bright little kid to grow up in a house full of chemicals.
The humors, right?
Yeah. Oh yeah. So he's like mixing chemicals up and stuff. So you know, maybe it wasn't such a bad thing. Maybe he was better off living with the apothecary. Maybe we can thank his nasty stepdad for kicking him out and making him go live with the apothecary, where he grew up fascinated in the world around him and also rather disturbed.
Oh.
But anyway, there's your little insight into Newton. I was talking about that in astronomy and thought that was interesting to bring up. Yes, you can read the whole list. He even has 2 lists of sins. One of them is before Whit Sunday, 1662, and he also had some other sins after Whit Sunday, 1662. Yes? Yes. Okay, so let me say who's not here, and then let's learn what we can in 45 minutes. Oh, I've just started another class. Dang it.